Could the future of space travel lie in harnessing the power of light? In a universe where lengthy star treks could be completed in mere decades, we find ourselves contemplating this fascinating possibility. This isn't just imagination. It's a reality currently being explored by some of the brightest minds in astrophysics. The Breakthrough Starshot Initiative is at the forefront of this audacious journey, aiming to make star travel a reality through light propulsion. Guided by the brilliant British astrophysicist Dame Dr. Maggie Adaran-Pocock, the project is planning to utilize solar sails to traverse the cosmos, driven by lasers. This isn't a lazy sail, it's a grand vision to surf light waves across galaxies. The success of this approach hinges on the spacecraft design. The project emphasizes the need for compact, lightweight probes capable of transmitting images back to our planet. The future likely holds a drastic shift in space travel, moving away from enormous, heavy spacecraft to slender, fast probes racing through the universe on light beams. This could mean a radical shift in the way we perceive space travel, moving away from massive, bulky spacecraft to lean, agile probes zipping across the universe on beams of light. Light isn't the only game changer in this story. The ever-evolving arena of space travel introduces the concept of antimatter engines, marking the forefront of this revolution. These futuristic wonders might drastically modify our understanding and engagement with space exploration. Antimatter, upon annihilation with regular matter, creates an energy output that's stupendously powerful. Safely and economically harnessing this energy could catalyze a sea change in rocket propulsion. Despite hurdles, progress is steady, albeit slow. Meanwhile, a tangible revolution is already underway. The electric vehicle industry is now powered by solar energy, with pioneering startups like Aptera at the helm. Aptera has recently debuted a remarkable solar vehicle that eliminates the need for charging. It comes equipped with 700 watts of solar panels, facilitating 40 miles of solar-empowered driving daily. This vehicle establishes a model that might extend to spacecraft, particularly in the realm of light-driven travel. This vehicle sets a precedent that could extend to spacecraft, particularly in the field of light-powered travel. So, what does the future hold for space travel? The upcoming era could be revolutionary with the advent of light-speed travel. Concepts like solar sails, antimatter engines, solar-powered vehicles, all seem far less fictional now. As science progresses relentlessly, these hypothetical technologies are inching closer to reality. Competition to materialize these ideas is fierce, creating an environment ripe with innovation. The prospects emerging are nothing short of exciting, hinting at a future where space explorers could be preparing for a journey to the stars at light speed. However, the path to light-speed travel isn't without its hurdles. As we delve deeper into the realms of interstellar travel, we are confronted with a plethora of scientific enigmas and technical challenges that must be resolved. Among these, the potential of antimatter engines and solar sails is particularly fascinating, although equally challenging. Let's first consider antimatter engines. This technology is based on antimatter, an intriguing substance that is the exact opposite of the matter we encounter in our everyday lives. When antimatter comes into contact with normal matter, it leads to an energy release. This energy, theoretically, could be harnessed and used for propulsion, driving a spaceship at unparalleled speeds. However, the realities of antimatter engines are vastly complex. The first challenge lies in the creation of antimatter itself. This requires immense amounts of energy, far beyond what is currently achievable with our contemporary technologies. The next challenge is storing and effectively controlling antimatter. The delicate nature of antimatter requires immaculate precision and control, as any mishap could lead to disastrous consequences, potentially even resulting in the complete annihilation of the spacecraft. Next, let us move on to solar sails. The basic concept of solar sails is simple. These ultra-thin sails, possessing a mirror-like quality, capture momentum from photons, the fundamental particles of light, and use this momentum to propel a spacecraft forward. However, the execution of this concept is far from straightforward. Designing a solar sail involves a delicate balancing act. The sail must be large enough to catch a sufficient amount of sunlight, yet light enough to be practical for use in space. Additionally, navigating a spacecraft propelled by solar sails through the vast, unpredictable expanse of space is a challenging task that requires precise calculations and advanced technologies. Beyond the technologies of propulsion, we also need to consider the harsh conditions of space itself. Spacecraft must be built to endure extreme temperatures, high radiation levels, and the vacuum of space. They need to be constructed out of advanced materials that are both lightweight and extremely durable, capable of withstanding these harsh conditions for extended periods. All of these challenges, while daunting, have not dampened our quest for light-speed travel. Instead, they have served to fuel our determination, pushing the boundaries of human ingenuity and technological advancement. Each obstacle we encounter and overcome brings us one step closer to realizing our dream of journeying amongst the stars. So, as we look to the future of space travel, let's remember the challenges that lie ahead and appreciate the incredible work being done to overcome them. If you like this video, don't forget to rate, subscribe, and share so we can keep you up to date on what's important in our tiny fraction of the universe. And as always, take care.